You can even type your answers also, okay, in the chat box. Yes, no, something like that you can type. Or if I want any specific reply, I would, ask you to unmute and talk about it. Okay. Now, in AEC, okay, or to that matter, in any course in engineering, we will be having 5 modules. 5 modules. Okay. Now, with respect to AEC, okay, let me talk about. In module 1, you will be studying about 2 parts. Okay. Diode circuits as part 1. And in part 2, you will be studying about transistor biasing. Okay. On the other hand, in module 2, you will be studying about transistor at low frequencies. Okay. We'll be studying about transistors at low frequencies. Okay. On the other hand, in module 3, it is consisting of 2 parts. Multi-stage amplifier and feedback amplifiers. Okay. Then we will have the module 4. It is again consisting of 2 parts. Power amplifiers and oscillators. And then finally, the last module. Here you are going to talk about FETs and MOSFETs. FETs and MOSFETs. Okay. Now, okay. Module 1, if you look at, okay, the first part is what? Diode circuit. Now, in this diode circuits, we will be talking about clippers and clampers. Okay. Now, in specific to clippers and clampers, I don't think so you have studied in diploma. Okay. But these clipper circuits, okay, are somewhat, similar to your HWR, which is half wave rectifier circuit. So you can understand clippers provided you understand half wave rectifier circuit. Okay. Clampers is a new circuit. I don't think so you have studied about clampers in diploma. No problem. Okay. And transistor biasing, as I was mentioning earlier, I was saying that in transistor biasing, there will be something like fixed bias circuit, voltage divider bias circuit, etc., etc. Okay. I don't know whether you have studied or not. Probably when I start drawing the circuit diagrams, you will be able to recall whether you have studied or not. Okay. So module 1 is very easy to understand and very easy to score as well. Okay. That's because you have already studied something about the diodes as well as transistors in your diploma. Okay. Module 2, I don't think so you have studied in diploma. Okay. This is little advanced level, but easy to understand. Okay. Same case holds good for module 3 also. Slightly different topics, but the understanding remains the same. Okay. If you know what is a transistor, you will be able to understand multi-stage amplifiers as well as feedback amplifiers. Okay. If I were to talk about the complexity levels, okay, complexity levels of these modules, I would say module 1 is easy. Okay. Module 2 and module 3 are, you know, they are moderate. And module 4 is again easy. Okay. Module 5 is also easy. Okay. Why I'm not discouraging you guys, okay, because I want to tell you the exact picture so that you will be prepared for it. Okay. So module 1 is pretty easy to understand and pretty easy to score as well. So as module 4 and module 5. Okay. Module 2 and module 3 needs good amount of hard work from you guys. Okay. Uh, my teaching alone is not sufficient. Okay. You have to put your hard work. Okay. On the other hand, 1, 4 and 5 can be easily understood. Okay. Now in your exam, Babu sir, 100 marks question paper or 80 marks? 100 marks, right? Yeah. So 60, yeah. In every module, in your external exam, you will be getting uh, questions worth 20 marks. Okay. So module 1 will have 20 marks questions, and this module 1 we will have it will have two parts. Under module 1 you will have question number 1. Majorly, it at the maximum it is consisting of 4 subparts. Either you have to answer fully question 1 from module 1, or fully question 2 from module 1. Okay, so two questions will be set. Either you attempt question 1 fully or question 2 fully. Okay, uh, that's how it is being done. Similarly, from module 2, 3 or 4 will be coming, and module 3, 5 or 6, and this becomes 7 or 8, and this becomes 9 or 10. So altogether there will be 10 questions. Okay, but you will have to attempt only 5 questions. Okay, so when you attempt these 5 questions, you make sure that you attempt a particular question fully. In the sense, for example, let's say I have question number 1, which is consisting of 4 parts. Similarly, I have question number 2. This is just an example. It is also consisting of 4 parts. Let us say this is, say, 8 marks, 8 marks, 2 marks, 2 marks. So 8, 8, 16. Okay, 2 to 4, so it is 20. Right. Similarly, somewhere here it is 4 and 4. Now let's say you know this particular question and you know this particular question. You will attempt these two questions. Okay, so you will get, let's say, 16 out of 20 from this. And in question number 2, let's say in question number 1, you don't know part C and part A. Instead, you knew, let's say, part D of question number 2. You will attempt this. Okay, and for this question, you will get 4 out of 20. Now, remember one thing: the totaling is done by the computer software. So the computer will pick the bigger number. Computer will simply pick the bigger number and it will just allocate the highest marks, that is 16 by 20. You never think that this 16 gets added with this 4 and you will get 20 out of 20. No, it cannot happen. It won't happen also. So don't do cross attempt. Okay, what I'm trying to tell you is that either you attempt fully question number 1 or fully question number 2. That's how you have to prepare. Okay, now how do you ensure that you will be in a position to answer a complete question? That's possible if you read the entire content of a particular module. If you read, let's say, 40% from module 1, 40% from module 2, etc., etc., and for your bad luck, if they do not ask any questions from the content what you have read, then you will be in trouble. So what I am trying to tell you is that ಅರ್ಧಂಬರ್ಧ ಎಲ್ಲ ಮಾಡ್ಯೂಲ್ಸ್ ಇಂದ ಓದೋದು ಬದಲು, you can actually pick some 4 modules and study those 4 modules completely, so that the probability of scoring good marks, I won't say probability of clearing the subject, I'm very sure that you can clear the subject very easily, but probability of scoring the marks will be greater if you study the full contents, okay, from let's say 4 modules, rather than studying here and there bits and pieces from all the 5 modules. Okay, so that's how you have to prepare for AEC course. Okay, and remember, whatever I have told, it is solely with respect to my course. I'm not pulling any other course into this discussion. Okay. Okay. Are you clear with the exam pattern, the external exam pattern? If you have any doubts, please unmute and discuss with me. Why am I not getting any reply? Do you have any doubts? No? No doubts? Okay. Fine then. Now, great. So now let me start with the subject discussion. Okay. So what I will do, I will start with module 1, and topic is Clippers. Okay. First, let me talk about the definition. Okay, as the name suggests, clipper. Clipper means what? Clipping. It's like a scissor circuit. Scissor is used for clipping or chopping the paper, right? So similarly, in an analog electronic circuit, we use clippers to chop the waveform. So basically, clippers, it shapes the waveform for a desired value. So clipper circuits are nothing but wave shaping circuit which shapes the waveform for a desired level. So these clippers are sometimes also called as wave shaping circuits, or even it is also called as slicing circuits. Okay. Fine, that is about the definition. It cuts the waveform or it shapes the waveform for a desired value. Example, have you come across any wave shaping circuit? You have come across a wave shaping circuit called as half wave rectifier. So half wave rectifier circuit is an example for clipping circuit. The question is on what basis I'm saying that it's a wave shaping circuit. Okay, so for that, first let me draw the circuit diagram. So in case of half wave rectifier circuit, let us say this is your input voltage Vi, which is AC in nature. That's the reason I have drawn the sign symbol here. You will connect a diode in series with the AC source. This is the anode terminal of the diode, and this is the cathode terminal of the diode. Okay. And let's say this is your load resistor, RL. and this is your output voltage V0. Okay. Now, let us assume that, so let us assume that diode is ideal. Okay. Can anyone tell me what do you mean by an ideal diode? So ideal diode is a diode which acts like short circuit when forward biased. Okay. And it acts like an open circuit when reverse biased. Okay. So this is a way of analyzing your clipping circuit. You can either consider your diode as an ideal element, or you can even consider the diode as a practical element. Just a minute. Yeah. Fine. So let us look at the analysis now. Now, in case of Clipper circuit, in the analysis, what we do is we consider positive half cycle of input and similarly we also take a negative half cycle of input. This remains constant. I mean, this what do you say, analysis sense remains the same throughout the analog electronics course. Okay, whenever you have a circuit, whenever the circuit is energized by a sinusoidal function, to analyze the circuit, what we do is first we consider, say, positive half cycle, and then we consider a negative half cycle. So over a cycle, we know what output we are going to get. That is what we are trying to do it in analog electronic circuits. So for positive half cycle, okay, you will get some output. Similarly, when you consider the negative half cycle of the input, you will get, some other output. Put together, you will get a cycle of output. Okay. So let's see what will happen for the positive half cycle. Okay. As you know that in case of AC signal, you cannot put plus or minus polarities just like that. Okay. You can put plus and minus sign only if you consider either the positive half cycle or the negative half cycle. That's the reason you need to take care of these analysis very, very carefully. So first let me consider positive half cycle. Okay. So what happens to the diode circuit when we consider positive half cycle of the input? So to facilitate the positive half cycle of the input, what I'm going to do is that I will write the upper side of the source with positive sign and the lower side of the source with negative sign. Okay. So plus and minus sign indicates that we are under the positive half cycle. Okay. And remember one thing, you cannot fix the polarities for AC. Okay. You have to mention whether you are considering positive half cycle or negative half cycle. Fine. So we have fixed the polarity for positive half cycle. And the remaining part of the circuit remains the same. Now, if you look at the circuit, you can clearly observe that the positive part of the battery or the positive terminal of the source is connected to anode. So whenever the positive terminal of the source gets connected to the anode, we say the diode is forward biased. Correct. So when positive terminal of source is connected to anode, the diode is forward biased. So when the diode is forward biased, what is that you are supposed to do? I have already mentioned in the beginning that when the diode is forward biased, we are going to replace the diode with what? Short circuit equivalent. So if the diode is forward biased, replace the diode with short circuit equivalent. So let us do that. This is my anode and this is my cathode, right? What I'm going to do, the diode I'm going to replace with a short circuit. Short circuit means a simple wire you are supposed to draw. Okay, and then comes the load resistor RL, across which we will measure the output voltage. This is my VI plus and minus I, and this is my current I. So therefore, my output voltage V naught is basically current into resistance, that is I into RL. So output voltage V naught is I into RL. Okay, now across, I mean, in between RL and VI, what is present? Between RL and VI, what is present? Only the wires are present, right? Let me draw it with pink color. So between source and the load, only wires are present. That means to say there is no voltage drop in these wires. So you can also say that output voltage is equal to input voltage. In case of half-wave rectifier circuit, under the ideal diode condition, when the diode is in conduction, the output voltage is given as I into RL, which is equal to the input voltage. Okay, that is because if you connect a voltmeter across the load, this particular voltmeter is going to read the input voltage itself, right? That's because your source is directly connected to the load resistor. So there is no intermediate resistance coming in between the source Vi and load resistance RL. So V naught is equal to Vi. So you remember one thing, what did I say? In the analysis, we consider positive half cycle of the input and we try to take out the output. So here we are. So this is our output. So what is your output? Your output is equal to input. That means to say AC wave it is. So your output is nothing but input. Since input is AC waveform, so it is output is also AC waveform. So in bracket you can write positive half cycle. All right, fine. So that's about the positive half cycle. Now let us see what will happen when you consider a negative half cycle. Now, when you consider a negative half cycle, what is that you need to do first? You need to change the polarity of the source, right? So this is how the polarity of the source being given for negative half cycle. You have to invert the polarity. The diode connection remains the same. You have anode terminal and then you have cathode terminal, and it's been connected to the load resistor RL as well. Now, can anyone tell me what will happen to diode conduction? As you can clearly observe that the anode terminal of the diode is connected to the negative terminal of the source. So when negative terminal of the source is connected to anode, diode gets reverse biased. Diode gets reversed biased. Okay, so due to which the equivalent circuit looks like this. Okay, now how do we handle the reverse biasing condition in the diode? As I have already mentioned, whenever there is reverse bias, you need to replace the diode with an open circuit. So this is what it will happen. So this is a source minus plus. So are we going to keep the diode symbol? No, we are not going to keep the diode symbol because the diode is reverse bias. So there will be a physical separation between anode and cathode terminal in the equivalent circuit that shows that the current flow through the device is zero. All right, so this is your RL and this is my V0. Okay, the current flow normally we take from negative terminal to positive terminal. It should have been in the anti-clockwise direction, but there is no current because there is open circuit. Due to which, what happens to my output? Can anyone tell me what is the value of output? Your output is nothing but current into load resistance. Current is zero and there is resistance. The product becomes 0 volts. Okay, so for negative half cycle, your output is equal to 0 volts. So why it is called as Clipper then? As you can clearly observe that even if there is negative half of the input, okay, even if there is input, the output is 0. So for the negative half cycle of the input, output is 0. So basically you are removing the negative half cycle from the signal. And that is the reason half wave rectifier is called as a Clipper circuit or a wave shaped circuit. Okay, so here I can write the negative half cycle is removed from the output. Okay, hence it is called as a negative clipper. Getting the point? Hence it is called as a negative clipper because negative half wave is missing. Okay, so this is the working of a simple clipping circuit. Okay, so there can be different circuits. You can also have a positive clipper. Okay, but the overall working or the sense in which we carry out the analysis remains the same. Okay, so we got an output for negative half cycle also. Now what we will do, we will present this output in a meaningful way. So for that, what I will do, just draw the waveforms. Okay, this is my time axis for the input. And this is my time axis for the output. This is my time axis. All right. So this is my input. I'll use white color. And this is my output. Okay. So let me draw the input waveform. So input is sinusoidal, right? So mark the points: 0 degree, 180 degree, 360 degree, okay, 540 degree, 720 degree. Then also mark the transition points because you need to draw the output waveform, right? So this is how you can draw the transition points. All right, done. So input we have drawn. Okay, now we need to draw the output. Okay, so how do we draw the output? So in order to draw the output, we have to go back to our analysis. So for the positive half cycle, what is your output? For the positive half cycle, output is I into Rn, which is nothing but the positive half of the input itself. So for the positive half cycle, okay, for the positive half cycle, output will be the replica of positive half cycle of the input. So the same wave will appear in the output. Okay. So that's your output for the positive half cycle. Next, let us handle the negative half cycle. So for the negative half cycle, what is the output? 0 volts. So when there is negative half cycle of the input, the output remains 0. That means to say you will have a straight line overlapping with the time axis. And in the next positive half cycle, what happens? In the next positive half cycle, once again, the Clipper output becomes positive half cycle. So you'll have a positive half cycle. Okay. Once again, in the next negative half cycle, the output of the circuit becomes 0. Hence, you will have a 0 volt level signal. And this continues one cycle after the other. Now, if you carefully observe the output waveform, you can clearly observe that in your output waveform, which part is missing? The negative half cycle is missing, right? So the negative half cycle of the input you have removed. That's the reason your output is consisting of only positive half cycle. Okay. So here let me write negative half cycle is clipped. And that's why it is called as a negative clipper. A negative clipper. Okay. All right then. So that's the output. Okay. Did you understand? You can type yes or no in the chat box.
Yes, sir.
Okay. Okay. You have understood because this is half wave rectifier circuit, right? And you have studied half wave rectifier circuit. So what I'm trying to tell you is that whether it is half wave rectifier circuit or whether it is modified half wave rectifier circuit, that is immaterial. Okay, whatever may be the circuit, being an engineering student, what you need to take care of is the analysis part. Okay, so the analysis remains the same. So always all your Clipper circuits you try to analyze with this logic. Okay, you don't have to read the textbooks, you can just follow my method and you can just do it off. Okay, so don't worry about it. Okay, so waveforms you have drawn, and waveforms you have been drawing in your diploma as well. Okay, but there is one addition in engineering is that you need to draw the transfer characteristics. Okay, so I'll tell you what exactly the transfer characteristics. Now, waveforms are always drawn with respect to signal value versus time, right? Either it could be I versus t or v versus t. In case of transfer characteristics, okay, we draw the transfer characteristics with respect to input variable to output variable. Okay, for example, output voltage to input voltage or output current to input current. So that is my transfer characteristics. Now, in the transfer characteristics, what I'm going to do is that I'm going to draw the relationship between input voltage to output voltage. Okay, draw the relationship between input voltage to output voltage. So for transfer characteristics, here I will write the y-axis as output voltage axis and x-axis as input voltage axis. Okay, so this is my first quadrant. So V0 and Vi is positive. On the other hand, in the second quadrant, output is positive. My input is negative. What do you mean by negative input? Negative input simply means that the negative half cycle. Similarly, in the third quadrant, both input and outputs are negative. Once again, the negative output means that the output is basically the negative half cycle. And finally, we have the fourth quadrant. So in the fourth quadrant, input going to be positive and output going to be negative. All right, fine. So now let us handle the transfer characteristics. So in transfer characteristics, what you have to do is that you have to first consider part A, which is positive half cycle. And then you consider part B, which is the negative half cycle. All right. Now, in the positive half cycle, what did we get? In the positive half cycle, we got V0 is equal to Vi. Okay, V0 is equal to Vi in the sense when your input is 0, output will also be 0. On the other hand, when your input reaches the maximum value, that is Vm, let me write Vm here, the output will also be reaching its maximum value. So when your input is 0, output is 0. When your input is Vm, your output will also be Vm. So basically, you will get a straight line. So this is your transfer characteristics for the positive half cycle. Control ZW. I'll use a line. Okay. So this is my transfer characters. I'll just change the color so that visibility becomes better. Okay. So this is for the positive half cycle. Okay. Now in the negative half cycle, as you can clearly observe, when the input is 0, right? When the input is 0, what is your output? Output is also 0. So that is nothing but tracing the origin. But when your input attains minus Vm value, what happens to output? Output will be at 0 volt level. That means to say, even when your input attains the negative value, the output remains 0. That means to say, the line is parallel to x-axis and basically it overlaps. Okay, basically it overlaps. Okay, so this is your transfer characteristics for a half wave rectifier circuit. So always remember, I'll tell you a shortcut. When the output voltage is DC. Transfer, in short, let me write, transfer characteristics will be uh, transfer characteristics will be a line parallel to x-axis. Okay. On the other hand, when the output voltage is AC, the transfer characteristics will be a line inclined with respect to x-axis. Okay, so it will be an inclined line. You can see now it's an inclined line. So in short, what you can write is that this is DC and this is EAC. Okay, so this is your transfer characteristics. All right, so
Sir,
yes,
sorry to interrupt. We have another class, sir.
class. I know. That's the reason I was about to tell you that. Okay, so that's it for the day. So I'll give you an homework. Okay, draw V naught versus time, Vi versus time, and plot the transfer characteristics. Okay, and the circuit is this. Just to give me 1 minute. Sinusoidal source, but the diode connection is something like this. Cathode is here, anode is here. This is RL and this is V naught. Correct. Okay. So for this particular circuit, draw the input and output waveforms and also draw the transfer characteristics. Okay, let me check tomorrow. Okay. That's it for the day. This recording will be shared with you. Okay. Thank you.